Okay, section 12.3. See, that really is what it is. All right, cylinders, which I know you've had before too. So we have my usual stuff to write with and highlighter, which right now means it's important for you to know, not something I'd say needs to be committed to memory all the time. So a cylinder may be thought of as a prism whose base is a polygon having infinitely many sides. In other words, it's a circle. They're congruent circles contained in parallel sides. I know you know what a cylinder is. I'm not worried about it. You know that the top is the base, the side makes up the lateral surface, the axis connects the centers. All this is down here. The radius, of course, is the radius of the base, and the base is, that's the other base down at the bottom. This is a right cylinder because it has right angles on its axis, whereas this is an oblique cylinder because it does not have a right angle. Its altitude is out some, whereas its axis is over here. Sometimes your altitude and your base will meet outside of the cylinder. That's okay. It's not a big deal. Just a line. It's okay. So there's that information there, which leads us to the next page. At the top, they talk about the altitude of a cylinder, which is basically the height of the cylinder along wherever it is a right angle with the base. It doesn't matter if your cylinder is like over here or not. To form a right angle, doesn't matter if your right angle's inside the cylinder or not. What matters is that it is a right angle with the base, connecting the top base to the bottom base. Okay, then they jump into the formulas. The lateral area, L, of a right circular cylinder equals the product of the circumference times the height, or 2 pi h. So L equals 2 pi h, because that's more convenient, the circumference. So when you're looking at it and looking down here at this one, because I don't have a good picture up here, looking down here at this one, our lateral area is going to be the area of the rectangle around the outside. If you were to take a can of beans out of your mom's cabinet and you were to take the label off, when you undo that label, then you find out that the label is actually a rectangle. And the length of this top of the rectangle is going to be equal to the circumference around the can. That's where they're getting the circumference from. And once you take that circumference and you multiply it down, you are going to get the lateral area. And then they talk about the base, or sorry, the total area of the right circular cylinder equals 2 plus the lateral and the two base, equals the lateral plus the two bases, or it equals that. That's the one that you're going to want to write down. This one right here. Okay, so let's look at these two problems right here. Actually, I'm just going to look at this B. So it says that my height is 3 and that my diameter is 16. So I need to find 2 for my lateral area. I need 2 times pi times r times h. 2 times pi, the radius would have to be 8. That's my r, and my h we said was 3. So my lateral area is going to be 16 times 3, that's 48 pi inches squared, because we're talking about area. Hey, look, we were right. Then they want the total area, so I have to find the area of my base. Area of the base, or just the big B, is going to equal pi r squared. So that's going to be 64 pi, because it was 8 times 8, which is 64 pi inches squared. So my total is going to be 48 pi plus 64 pi. And since pi works just like x's, that makes this a total of, oh, sorry, there's another 64 pi. Because we got a base on the bottom and a base on the top. So that makes this a total of 176 pi inches squared. Now, that's not how they chose to solve it. They actually used this formula. 2 times pi times 8 for the radius, times 3 plus 8, which is 11. And you get 176 pi inches squared. They never told me up here in my directions what to let pi equal, so I know I need to leave it in my answer. If they were to say, let pi equal 22 over 7, then I'd put in the 22 over 7. If they were to say, let pi equal 3.14, then I'd put in the 3.14, but they never said, so I don't put. All I do is leave it in pi. Then they want you to find the volume of a cylinder. And they go ahead and give you the formula for that. The volume of a cylinder equals V equals base times height, or in this case, pi r squared times the height. So just like it was for a right pyramid, you find the area of this, not the perimeter, but the area of this, and then you multiply going down by the height, not by the axis. So here, they didn't tell me what my bottom was, but they did say that that was 60 degrees. That makes this a 30, 60, 90 triangle in here, which means that if this is 8 inches, this bottom here must be 4, and this must be 4 square roots of 3. I know that because I know my 30, 60, 90 triangle. So since this is 4 square roots of 3 for my height, I can go ahead and use this formula up here to find my volume. Pi is just going to be pi because they didn't say what pi should be. R, they went ahead and told me that this was 6 inches all the way across, so my radius is going to have to be 3 inches. And then that one gets squared, and then we have the height of 4 square roots of 3. That's going to be pi times 9 inches squared times 4 square roots of 3. Remember, it's outside times outside, inside times inside. So volume equals pi times 9 times 4 is 36. Square roots of 3 inches squared. Oh, it should be cubed now because it's volume. The only thing they did different was they put the pi in the back. Otherwise, they got the 36 square roots of 3. This 30, 60, 90 triangle comes back over and over and over and over again. So does a 45, 45, 90 triangle. So make sure you keep reviewing those if you start to forget them. Okay. Thus endeth section 12.3, which means we are ready for classwork and homework. So I'll come up here on page 504, which is what page I'm looking at right now. The classwork is numbers 3, 7, 11, and 17. And the homework is numbers 5, 9, and 15. You can tell you're filling out charts, but they work just like the other ones did. Nothing scary. See you next time. Have a good day.